Do people understand the scale of the universe reaction? Hello, wonderful followers of Understanding the Universe. We're so grateful to have you here as part of our cosmic journey. Your support and enthusiasm fuel our mission to explore the mysteries of the universe and share its wonders with you. If you enjoy our content, we kindly remind you to hit the like button, subscribe to the channel, and turn on notifications so you never miss an update. Your likes, comments, and shares mean the world to us and help us grow this amazing community. Let's continue exploring the universe together. Thank you for being part of this adventure. The scale of the cosmos exceeds the bounds of human comprehension, but that doesn't mean the universe is beyond our understanding. Space is big, that's why we call it space, but how big is big? That's relative. When an astronomer says something is nearby, they might mean it's a few million kilometers away, if they're talking asteroids, or a few tens of trillions for stars, or a few tens of quintillions for galaxies. No matter the destination, it's a long walk. We make it easier on ourselves by using huge units to measure distance, such as a light year, the distance traveled in a year by light, the fastest thing in the universe. A light year is about 10 trillion kilometers. But that's still fairly abstract to the typical person reading casually about nearby exoplanets or distant galaxies. One way to better grasp this scale is to take it step by step. The moon is the closest astronomical object to us in the entire universe. On average, across its orbital path, it's about 380,000 kilometers from Earth. That's already a pretty long way. Nearly 30 Earths could fit side by side over that distance. Or think of it this way, the Apollo astronauts, traveling faster than any human before them, took 3 days to reach the moon's vicinity. The sun is about 400 times farther away from us than the moon is, 150 million kilometers. How far is that? If you could pave a road between Earth and the sun, it would take you about 170 years to drive there at highway speeds. Better pack a lunch. A commercial jet would be better. It would take a mere 17 years. When we work with objects inside the solar system, it's convenient to use the Earth-Sun distance as a kind of cosmic meter stick. We call it the astronomical unit, or AU, and it is defined by the International Astronomical Union, the keeper of all astronomical numbers, names, and other such agreed-on conventions, as exactly 149,597,870.7 kilometers. Mercury is about 0.4 AU from the Sun, and Venus about 0.7. Their distances from Earth depend on where all the planets are in their orbits and increase when respective planets are on opposite sides of the Sun. So Venus will range from about 0.3 to 1.7 AU from Earth. Neptune, the farthest major planet from the Sun, is 4.5 billion kilometers out, or 30 AU. Pluto's at roughly the same distance, and it's a long way from us. The New Horizons spacecraft took more than 9 years to get there, despite moving at speeds of more 50,000 kilometers per hour. These numbers are still difficult to grasp. When I traveled to schools to give demonstrations to kids about astronomy, one of my favorite props was the solar system rope, a hefty 15-meter cord that represented the average Sun to Pluto distance. The students were given photos of planets, and we'd place them at the proper scale distance from the Sun. The inner 4 planets were so close together that the kids were practically on top of one another, but the outer planets were spread out a long way. We had to either find a long hallway or go outside for the demo. That lesson proved so popular that I created a spreadsheet allowing anyone to calculate the solar system to scale. It's based on the size of the Sun, so you can change it from the default of 1 meter to, say, the size of a grape and find out how big and how far off the planets become. It's fun and eye-opening. But it's useful, too, to consider the separation between objects in terms of their size. For example, the Sun is 1.4 million kilometers wide. The nearest star system to the Sun is Alpha Centauri, which is 41 trillion kilometers away. If we divide the second number by the first, we find that Alpha Centauri is about 30 million suns away. Stars are very small compared with the distance between them, and that is one reason you really don't need to worry about one ever colliding with our Sun. That's also why we use light years to measure these distances. It's a more palatable unit for dealing with interstellar journeys. Alpha Centauri is 4.3 light years away. The Orion Nebula is about 1,250 light years from the Sun. The center of the Milky Way is 26,000 light years away, and the galaxy itself is a flattish disk, some 120,000 light years across. The nearest big galaxy to the Milky Way is Andromeda, which is 2.5 million light years from us. That's an interesting number because it's only 20 times the size of the Milky Way. Most galaxies are pretty close in size. Inside galaxies, stars collide extremely rarely because they're so far apart relative to their size. But galaxies are more crowded together in space, so it's not too big a surprise that galaxy collisions are not only common, but ubiquitous. The Milky Way grew to its tremendous size by colliding and merging with other galaxies, and in fact every big galaxy has undergone multiple collisions. The Milky Way and Andromeda are the two biggest galaxies in a clutch of about 100 galaxies that we call the Local Group. It's about 10 million light years across. There are even bigger and more populous groups called galaxy clusters. The nearest big one is the Virgo cluster, with well over 1,000 galaxies in it, located about 50 million light years from us. And smaller groups exist that are closer to us. Galaxy clusters are held together by the gravity of their members and can be tens of millions of light years wide. But we're not done. Clusters can clump up in the cosmos to form clusters of clusters called superclusters. The Virgo cluster and the Local Group are part of the Laniakea supercluster, which may have more than 100,000 galaxies in it and stretches for 500 million light years. The universe is 13.8 billion years old, so you might think the most distant objects we can see are roughly that distance away in light years. But the cosmos is expanding, and in the time it's taken for the light from distant objects to reach us, that expansion has swept them farther from us. Because of this movement, the observable universe is estimated to be more like 90 or so billion light years across. After all that, I'll let you in on a secret. Even astronomers can't truly grasp these scales. We work with them, and we can do math and physics with them, but our ape brains still struggle to comprehend even the distance to the moon, and the universe is 2 million trillion times bigger than that. So yeah, space is big, and it's true that we are very, very small. These scales can seem crushing. But I'll leave you with this. Although the cosmos is immense beyond what we can grasp, by using math and physics and our brain, we can actually understand it. And that makes us pretty big too. To our incredible Understanding the Universe community, we want to take a moment to express our deepest gratitude for your unwavering support and enthusiasm. Your curiosity, engagement, and love for exploring the cosmos inspire us to keep creating content that sparks wonder and knowledge. Whether it's through your likes, comments, shares, or simply by being part of this journey, you make everything we do worthwhile. Thank you for believing in our mission to unravel the mysteries of the universe and for being the heart of this channel. Together, let's continue to reach for the stars and uncover the infinite wonders of space.